the best way to describe calculus? Fundamentally, calculus is composed of three parts. We have the idea of a limit. The limit, we take all the ideas of college algebra, pre-calculus, and trigonometry, and we look at very small and very large things. Then we use the concept of limit to find the idea of a derivative, which is the slope of a curved line at a point. Not a straight line. In the past we found the slope of a straight line, but we're going to extend that using the idea of limits. Finally, we're interested in the idea of an integral. This represents the area under a curved line between two x values. Not a trapezoid or a rectangle or a triangle or a nice geometric shape, but a curved line. Again, we need the idea of a limit to do this. Limits can be very small or very large. Very small limits, if we take as our domain of a function the numbers from 0 to 1 inch, and we dissect that to a half, and to a quarter, and to an eighth, and to a 16th, and continue this process, and this is the domain, what happens to the range or the y values as we're doing this? That's for very small limits. On the other end of the spectrum, we have very large limits. Suppose as our domain we take very large numbers from 0 to a million, all the way up to a nonillion, 10 to the 30th power, and beyond. What happens to the y values as the x gets very, very large? This is also known as end behavior of a function. We continue with the idea of a derivative, and the derivative, if we take and draw a straight line through a point that is tangent to the curve, we have the idea of a derivative. And we'll be using the notation dy over dx for the derivative. Finally, we have the idea of an integral. If we have a function f and x goes from a value to b value, and we're interested in the area underneath the curve between these two vertical lines, and we'll be using the notation, the integral of f of x dx. Obviously there are many details left out, but this is an overview of describing calculus.